Okay, Daniel, are you actually done your thesis now?
I'm all done! These 2.5 years that I've studied and done my thesis, this is where I've been. This is where I've resided. And here's Melissa.
Hi.
With the little baby. This is my office space. I'm usually sitting right in the middle. My friend right to the left here, and my other lab mate here to the right. And oh, here's some horseshoe crabs shells that we saw. We found.
Look, they look like giant bugs.
They look like huge bugs. They even have their bug eyes. But they're awesome. Found 2 of them on the beach the other day in the Indian River Lagoon. Here's the tail that the telson that kind of fell off. But they shed. They shed like any other bugs, I guess you could say. They're crustaceans, and they'll shed their skin. And in fact, when they shed, they come out of this area right here and just crawl out from the back. And they leave that on the shore, so it's cool. Here's a cool little tank. It's for experiments. You put water in here, and you have this little thing that pushes the water this way, and as it goes, it flows around like this. And you can put things like trays and stuff there, so that you can see where they settle. My advisor did an experiment in this tank where he used oyster larvae. So the oysters larva would just float around, and then he would have different platforms here with different curvatures, and he wanted to figure out if the oysters had a preference on what curvature to land on. And this might be interesting to know for restoration. If you wanted a lot of oyster larvae to settle on things, and you knowing the right curvatures of what they have, of what they prefer, then that might be a good thing. There was one that was really curved like this, like a platform that was really curved. There was a platform that was flat. There was a platform that was a little bit curved, and as the water flowed over it, the plankton would settle. Plankton.
So where they choose to live, basically.
Exactly, like where they chose to settle, whether it was just luck, just the flowing of the water going over it, or whether they actually did have a preference. The definition for plankton is any organism in the ocean that will float around in the water and whose horizontal distribution, so floating side by side like this, is determined by currents. So meaning anything that can't fight the current is called a plankton. The largest plankton out there is a jellyfish. But it's also anything else that's very small, usually things that are very small, like plankton and SpongeBob, like that's a copepod. Those are plankton, they're just microscopic. And other larvae, fish larvae can even be plankton, things like that. Anyways, oyster larvae, also a plankton, because they just float around in the water current. This right here I used for my study. I did this for 2.5 years too, for seagrasses. The county wanted to find out if seagrasses were growing in the coming years, or if there was a change in seagrass growth. So what we do is we would go in the lagoon and put this down on the seagrass bed, and we would count the shoots coming off of here. So we see how many seagrasses are in each one of these. There's 100 of them, so like 100% percentile. And then as the shoots come out, you would count the shoots and determine how thick they are. Anyways, this is a tool that marine biologists use many times. If you look up marine biologists, you'll see these quadrats down on the bottom all the time. This is just a quadrat, and used to measure corals, mussels, seagrasses, anything that you find. Now here's a muffle furnace I used to burn organic matter to find out how much organic matter is in sediments. I find sediment, I get the sediment from the bottom of the lagoon, and I put it in these little trays, I dry them out, and then I smash them up, and I put them in these little trays here. See this right here? And then I burn it at a really, really high temperature. And at a certain temperature for a certain amount of time, I can find out the weight before and the weight after, and determine how much organic matter is in it by how much weight got burnt out. My thesis is on what the impact of organic matter has on little organisms in the sediment. So the muck and the sand. The sand has less organic matter. The mucky stuff, the muddy stuff, has a lot more organic matter. And I found that the more organic matter there is, the less species there are. So that's interesting.
So that means the muck has less species and the sand has more.
That's exactly right, yeah. Yeah. You can determine the health of the lagoon, as part of my thesis, by determining the amount of organic matter there is. So by simply taking the sediment, finding out how much organic matter there is, you can determine the health of that particular area of the lagoon. So it's an easy way of finding out the health. Oh yeah, here's some muck, for example. This is really mushy muck. Just looks like nasty stuff. Okay, that has a lot of organic matter. Organic matter is a compilation of, or an accumulation of living things. Living things all have carbon chains, which then turns into, which then is like organic, right? Organic chemistry, for example, all dealing with carbon chains. Things like plants, terrestrial plants, sewage, drift algae, lots of algae, either big algae or little tiny plankton too. Plankton can die off and become part of the organic matter. Seagrasses can be organic matter. Any living things that die can become that part of that organic matter in the sediment. Another student is it looks a little brown, and what she's doing is she's growing algae. These are different types of algae. Some of them will be super bright neon green. Some of them will look brown like this. So when you think of brown tides, that's what it is. It's just little microscopic algae that just grows like no other and turns the water a different color.
Is that also what red tide is?
That's exactly what red tide is too, yeah. Red tide, brown tides, all those things, that's all the microscopic algae that grows in so big of numbers that they discolor the water, which is pretty cool. Some of them can be toxic, and that's usually what you hear about in the news. They'll let off some toxins in the water, which even can be in the air, and it can make people sick. Has even killed people before, but usually not. Usually not. I'm never afraid of algal blooms. They can do harmful things to you, but mainly to the fish and wildlife. That's what everybody is afraid of, is that it just destroys the ecosystem for that period of time. Here's a bunch of microscopes. Dissecting scopes. You got a lot of different covers and slips, and in order to count the organisms in the muck and the sand, I use these microscopes and count them. Here's the thing I use to grab the organisms. It's called a ponar grab. This one in particular is called a petite ponar grab. As you put it in the water, it drops to the very bottom, boom, and that thing comes out. And once that thing comes out, when you pull it back up, it closes and grabs sediment with it. The reason behind what we're doing is the county wants to figure out how the lagoon's doing, and biological monitoring is called, where we monitor the biology. And in particular, what's going on is they're dredging this muck, actually, because the muck is kind of bad. So they're dredging this muck out, and they're trying to find out if organisms will start coming in, and if it'll be a more healthy place to be. So we've monitored before, during, and they're about to be done now. So, and then we're monitor the after. So with all that data, we're going to be able to compare to see if this dredging, if this is going to work or not. And since they're pouring millions of dollars into this to restore this lagoon, it's very important to get all the data you can. And that's what I'm part of. It's really fun.
You've just been there the whole time? The whole time Daniel was talking, Cedric was just looking out. You're done!
Done. It was, oh man, such a flood of relief. Anyways, I'm there on the desk, and the lady's looking over it, and I'm having almost a heart attack, because I'm wondering if she's gonna say, like, every little word she says. I'm like, no, don't make it. So I have to redo something. But then she finally says, she's like, all right, you've officially sent this in, and this emotion just came through me. I was like, oh my gosh, I can't believe this is happening.
Your relief?
It was a relief and happiness and joy, and just like, it's like, wow, like all this, and then like all these years of work you know, giving it like pretty much like finalizing it all. So it was good. It was a good feeling.
Here's some damage. All of the new wood for the fences here, it was blown away during Hurricane Matthew. But now they just rebuild it just now.
It was huge out in the ocean, but it didn't hit us as bad as it could have.
Yeah.
Une petite souris. Une maison de poupée. Une petite souris. Puis une brosse, un peigne et un bol plein de bouillie. Voilà, une brosse, un peigne et un bol. Il y a une vieille dame calme murmurant chut.
Hey.
Hey. Bonsoir chambre. Bonsoir les bruits de la terre.
At the end?
That's the end.
Alright, well, we're going to end the vlog for this week, but thank you so much for watching, and we'll see you next week.
Bye.
Bye.
Au revoir.